Roger has set the field for understanding the complexity of interaction that I'm looking at in human environment interaction, particularly the climate security nexus. And this is work that's done at the CLICS Excellence Cluster in Hamburg in my research group, Climate Change and Security, and I will refer to some work that's being done in this field. Complexity of these interactions you can see here between the climate system, which is the blue box on the left below, natural resources, human security, and societal stability, which has each of which has a lot of variables which are interacting with each other within the box, and you have the possibility to intervene to mitigation, adaptation, sustainability strategies. And focus in my research group is on the link between the climate system and societal stability, including conflict and cooperation. There's a lot of empirical work in this field of climate and conflict, in particular conflict risk is affecting climate change risk and vice versa, both in positive and negative ways. And this is moderated by governmental action to reduce conflict risk and by societal action to improve climate change adaptation. A study that was published in Nature 2 years ago was looking at the expert opinion of a group of experts regarding the most influential factors of climate change effect and conflict. And most of them found that in the past, at least, low socioeconomic development, low state capacity, and intergroup inequality were most influential factors on conflict, while climate change for the past at least was seen as less influential, but on the other hand, also the most uncertain factor. The question that was asked is what is the estimated probability that climate change needs to negligible, moderate, or substantial changes in conflict risk for 3 scenarios. Blue was the past, orange was 2-degree increase in the future, and red is 4-degree temperature change in the future. And the opinion was that there's a potential increase in the average from 13 to 26% of conflict risk with from the 2-degree to the 4-degree scenario in the future for a substantial increase of this conflict risk. On the other hand, it's possible to influence that interaction between climate and conflict through different policies. And another question that was asked for the 3 scenarios, whether these policies can have a substantial decrease, moderate decrease, or negligible change. And on average, it was about 25 to 30% option for a substantial decrease of the conflict risk, and moderate decrease was a little more, while negligible change was also on the same. But that means there is a potential for decrease, either moderate or substantial decrease of the conflict risk associated with climate change. And there are different policy options, of course, adaptation options like crop insurance for farmers or training services, as well as conflict mediation, peacekeeping, and building cooperation among those affected and those who could have an influence on the climate policy. The question is whether the future will move towards risk, insecurity, conflict, and violence, which is the red pathway, or towards sustainability, cooperation, resilience, and peace building in the future. And both options are possible through cascading events. And we have different tipping points, which are the black dots here, where there are decisions in one or the direction are made. The more you move down the red pathway, the crisis pathway, the more difficult it becomes to move on the sustainability pathway. You can do this for a global analysis as well as for regional cases. And you know that climate change has different regional impacts. On the one hand, having more droughts and in the Mediterranean region, in parts of Africa, and on the other hand, more flood and rain events and storms such as in South Asia and East Asia. You have the effect on rainforest, and you have also the effect on the Arctic region. All these are quite asymmetric and different. The question is, what is the impact of these climatic changes on social phenomena, including migration flows and conflict? And I wanted to study this in particular here for the Mediterranean region. And looking at this region, you see that the water distribution is an issue because of droughts, acidification, and impacts on different river systems as well as sea level change, which can have a contributing effect to the conflicts that are already existing in this region. And in the research of climate change and security, CLISAC, there have been a number of studies looking on the empirical side, for instance, of the vulnerability of climate change and water resources and social implications in North Africa, led by Jan-Peter Schilling, or on vulnerability of the Nile River Basin, coordinated by Michael Link, a study by Tobias Ida and colleagues on the pathways to water conflict during drought in the Middle East and North African countries. And finally, empirical work with researchers from this region, in the Jordan River region, on the tipping points in this conflict region associated with climate change. That was Miguel Rodriguez. And all of them found a deep embedding and integration of the natural phenomena and the social processes. And sometimes the social processes are stronger and have a bigger effect than the climatic changes, but the environmental changes are contributing here. Now, we have seen the Arab Spring about a decade ago was the complexity evolving between many factors here. And you see a major role is the dissatisfaction of people with their respective governments, which is the big factor on the lower left side, which is contributing to the conflict in the past already. But you see also that climate changes had an effect, for instance, weather extremes in areas with high crop production, such as China, Russia, and other parts of the world, had a contributing effect to food loss and food price increases in this region, which contributed to the protest. And there was a complex situation evolving, leading to regime change and to violent conflicts, such as in Libya or Syria, and an overthrowing of governments. And this led to instability, which contributed to refugee movements, which then moved either across the Mediterranean Sea or along the Balkan route to Europe, and contributed to instability there and to populist movements, and as well as terrorism. And yeah, there had been external forces that played a role here, like globalization, as well as policies by different actors like the United States or European Union, Russia. They were all taking part in these conflicts, and the United Nations was trying to moderate the situation somewhat. The question is whether in the future and in recent years, different policies had a positive effect, like adaptive governance across the multiple levels of climate diplomacy is indeed possible and happening, as well as solar decarbonization, and factors also using synergies in the food or water energy nexus, strengthening resilience and sustainable development and environmental peace building. So this is all attempts to contain the conflict in this region. Now, if you want to have a better understanding of the complexity, modeling can also help. I look now again at the 4 boxes that I showed in the beginning. In each of them, there are modeling activities, like on more climate models are looking at the relationship between precipitation, sea level extreme events, natural resources. There are many models on biomass, land, food, water, and fish. And on the side of human security, adaptive agents are important to model the interaction between various actions and their capabilities. And finally, the social interactions can be modeled to social networks to study the impact on migration, conflict, and cooperation. Yeah, the question is, where are possible tipping points into this interaction, cascading events? What is the role of sustainability and viability, and how are all these things connected to compounding events? Now, looking at the social dimension in particular, I want to introduce agent-based modeling, which was highlighted several times here at this workshop. We developed a model that's called a viable model that's understanding the interaction between human capabilities, which is invested in human actions, affecting natural and social systems, which are then evaluated according to values and goals by the agents. And then a repeated action cycle but they can adapt their behavior in a way that they better achieve their values and goals. These are some of the equations looking at the change of value, the change of cost of the agents and capability, as well the change in the priority of the agents according to the values and marginal utilities of the different agents to better adapt to achieving goals. Now, this model was applied here in 3 cases. We don't have an integrated model that includes everything, but we have done some modeling on some aspects. One aspect is the water conflict in the Nile River basin between 4 countries, Uganda, Ethiopia, Sudan, and Egypt. They can invest their capabilities in a better water use, a more efficient water use, and also water consumption. They can do this in a cooperative way with neighbor countries, but also in a conflictive way. Cooperation is given here by the green investments and conflict by the red investments. And the question is how this dynamics evolves between these 4 countries for 3 scenarios: baseline scenarios without climate change, reduced water availability by 20%, and increased water availability in the Nile River basin by 20%. And you see some modeling outcomes here for the 4 countries. Blue is Egypt, green is Sudan, red is Ethiopia, and then Uganda is the 4th country. For the 3 scenarios, you see that Egypt, for instance, is the strongest investments because they have also the biggest water problems. And that doesn't mean that necessarily they get more water because they're down the river and have a growing population. For that reason, the investment doesn't necessarily mean more water supply for this country. And this can contribute in the future to more a conflicting situation. Now, the second application in this area is the energy system and energy landscape in Egypt. There was Mustafa Shaban in his PhD thesis looking at this choice of energy systems in Egypt according to different criteria based on the data in the region, for instance, the population distribution or the water distribution on the left-hand side. And there were different the stakeholders asked with the question there what their priorities are for different criteria. And so experts, investors, policymakers, young researchers, and the criteria were economic, environmental, social, and technological criteria. And then they were applied to the choice of coal, natural gas, wind, concentrated solar power, photovoltaics, biomass, and nuclear energy. And for that, in this model, there was a construction of the priority of different stakeholders for the energy landscape. Blue, for instance, means here the initial situation in the simulation for natural gas, and yellow for solar, concentrated solar power, and how this changes over time, depending on certain assumptions which are given below in the change over time of the priorities of the agents for different scenarios. The third application, let me mention first that in a more recent paper which came out last week, there was also a comparison of this agent-based model of energy landscapes in Egypt with an optimization model that was already existing, the TIMES model below, and that had several scenarios for future energy supply. You see there is a difference between the LTAP model, which is the agent model, has a less energy for Egypt than the TIMES optimization model. And the optimization model also still has a stronger focus on the fossil fuels compared to renewables, but both, depending on the scenario, would give Egypt a lot of renewable energy potential, with some difference more to the solar energy in the agent-based model. Now, the third application is the application to migration patterns, in particular for pastoralist societies. And this is a modification, adaptation of the old sugarscape model combined with a viable model, where you have agents moving in a resource landscape, and basically they move from low resources to high resources. And the one adaptation here was social networks affecting this migration, both social networks in terms of family ties, as well as technological networks through smartphones and other communication devices for 4 different scenarios here. Above you see a high degree of technological social networks, and to the right-hand side, we see high degree of social networks being formed, and you see three different dimensions of mobility of the agents. One is the distance from the first resource distribution to the A, to the second B, and how the agents move over time and how much they move also during this process. And the third is the question is whether they're able to reach the area of high resources or not. And you see, for instance, a very strong response of the agents to high technological communication devices compared to family ties, which is a little more slower. But in both cases, you see a move, a change of the location of the agents between A and B. Okay, so these are three examples. Each of them individually can describe a phenomenon such as water, energy, and migration. But we have not integrated all of them yet, like in the food, water, energy nexus or migration conflict nexus, which is more the work of the future to connect these different things with each other. And this connection will bring together the climate projections of global and local climate change above with the different processes, for instance, between rural and urban areas, to migration, energy, food, and water. To find mechanisms and processes for strengthening social stability and cooperation and deal with the conflict. And different methodologies are case study analysis, both qualitative and quantitative, integrated in GIS platform, and methods of agent-based modeling. And with this, I want to stop here and happy to take any questions.